This is the UAS6 lesson for honors geometry. UAS6 comes after UAS4 where you just solved equations. So the two goals in this are to solve systems of two equations, meaning two equations whose intersection is the desired outcome. Last year in algebra you solved systems by three methods: graphing, linear combination, sometimes called elimination in other algebra books, or by substitution. So we'll go through a brief review of each of those three methods, but then taking it to what we're using it for in geometry. The point that we want in geometry is we want to be able to write equations of two lines, find their intersection to find the meaning of something like an incenter, circumcenter, orthocenter, or centroid. So anytime we're talking equations of linear functions represent lines. Lines have three possible ways of being on a plane in geometry. Lines can intersect, so the result of solving two equations that are linear might be that if we solve them together, we end up with the ordered pair for one point that is the solution to both equations and is their point of intersection. If the lines are parallel on the plane, however, solving the system will result in no ordered pair that's found to be on both. And if for some odd reason we graph two lines that are identical on top of each other, we would not be able to find an intersection because every point that's on one line is also on the other. We're mostly going to be dealing with this situation if we're talking geometric application, although every once in a while, parallels. So review from Algebra 1. When you solved systems last year, the system I have up right now would be wonderfully solved if we graphed. So if we graphed, we would set up our xy coordinate plane. We would use the slope-intercept form of these equations in order to get their graphs. And we would find, so this is the first one whose y-intercept is 1. The one whose y-intercept is -19 would look something like this, and its slope would be +3, so it would come up something like this. And our goal, graphically, would be to find the coordinates where that ordered pair comes together. My graph is rough and probably highly inaccurate. When we solve it by algebraic methods other than graphing, it can be quicker and more accurate if the ordered pair where they meet is not a set of integers. So last year you learned elimination or combination. The goal was to line up the two equations. The two equations in my system happen at the moment to be pretty well lined up. They have y's over y's, x's over x's, equal signs over equal signs, and constants over constants. Some people like to move theirs into standard form where the x's and y's are on the same side to solve by this method, but it's not necessary. To use this method, we have to have a way of combining the two equations by addition or subtraction and having one of the variables drop out or become 0. So at the moment, I'm going to take my second equation, I'm going to multiply everything in it by -1, and that is valid algebra as long as I multiply everything in the equation through by -1. Combining my two equations then leads to 0 y terms, -5 x terms, and +20. The goal is to have one variable drop out so that I can solve for one of my variables. So -20 would be -5x. Dividing both sides by -5, the x for our intersection would be at 4. Then we have a choice. We can take this x and plug it back into either one of the original equations or the two that we used for elimination and find the y value. I'm going to choose the top equation. Y is -2 times our x value at 1. So our y value is -8 plus 1, -7. These two lines would meet at the ordered pair 4, -7 if graphed. Okay, so this one's an algebraic method, the elimination combination, and the first one was a graphical method. So if we say solve algebraically, graphing is not one of your choices. Finally, substitution. Substitution allows you to do the same thing, only you would find the ordered pair by a different process. In substitution, your first step was to get one of your equations solved for y or x equals. One variable would be isolated. In this case, I already have one equation that's got one variable isolated, so I'm going to use a replacement value for y as -2x plus 1. I'll go to the second equation now, and instead of y equals 3x minus 19, in place of y, I'm going to substitute -2x plus 1 and the rest of my equations. So the replacement happened for the y, and now I'm going to solve this equation. Again, show good algebra here. No multiple steps per line. And you'd say, oh, you got the same x. Well, it's the same system, so the intersection point does not change, but it's the first part of your method that will change for substitution. The second part then is very much like it was for elimination. The second part would be to go back to one of my equations, plug in the variable whose value I found, and find the other one. So by either method, any of the three methods, I should still end up with the same ordered pair for intersection. Where we're going with it this year then is to have you do this and get some geometric equations out of it. So take a moment, decide what method you'd like to use for this one, just as some practice. When I look at this one, I already see it set up nicely for substitution because I see one variable is already solved for and ready to replace in the second. You could still do elimination and move some of your variables around. There's not a wrong choice there. I'm going to choose to do this one by substitution, so I'm going to rewrite my second equation as 4x plus 3 times the quantity. I'm going to replace the y quantity with its equivalent value, 0.5. A little distribution then, 4x plus 3x minus 12.75 is negative half. Okay, I'm now to one variable, which was my goal in the first place. Remember, you can pause this video, work yours out, double check your algebra, grab your calculator, whatever it might take so that you can accomplish this with us. And as you do this, and you do your division by 7, you end up with x being 1.75. So that's half my answer, but not my full answer yet. My answer will be complete when I have the ordered pair where those two would meet on a graph. It will not matter if I find x or y first. This just happened to substitute nicely for the y value. Then I need to take this and put it back into one of the two equations I started off with, or one of the equations that has both variables in it. I'm going to choose the first one because it's ready to substitute into for x and reveal the y value quickly. So 1.75 is the x value, plus a negative 4.25 for my y value. We end up with negative 2.5 for the y value. Whether you solve this by elimination or by substitution, that should be your value. You can always pause and rework this. One last one before we go on to the geometry part. I'm going to solve this one by elimination or combination. When I look at my two equations, they are lined up. What I mean by that is my x terms are above my x terms, my y's above my y's, equals above equals, and constant above constant. So they're in the same form. However, if I combine them right now, neither variable will drop out. I need to look for a plan. I can either try to get my x's to drop out or my y's. Either one will work here, but in the top equation, I see that if I multiply everything through by 3, I will have a new system that will be negative 6x plus 3y is 27. I'm aiming to get rid of my x's when I combine this time. I'm going to take the bottom equation, multiply everything by 2, multiplication on both sides. So 6x plus 4y is 8. Now my new system is going to have the same solution as my old system. However, combining them right away will allow a variable to drop out, 0 x's. So I have 7y is 35. My y value is 35. Remember, my goal is always a one variable equation that I can solve and find one value. And y is not 35, y is 5. Let's try that again. Going too fast. And find one value of my ordered pair. My plan after that is to go back to either these two equations or my original two to find my other variable's value. I'm going to return to 3x plus 2 times my y value being 4. So I have 3x plus 10 is 4. A little subtraction brings 3x is negative 6. A little division, x is negative 2. And my final part of my solution is set. Again, you could do that by substitution. I chose elimination just based on how the system was set up. So where are we going with this? we're going to be able to take geometrically your algebra skills and your geometry, put them together. So a triangle with its vertices given, to find something algebraically like the centroid. You've done parts of this before, so this is one new component to find the result algebraically. To find the centroid, dig in your vocabulary memory bank. Centroid is the intersection of the medians of a triangle. So algebraically, I want to come up with a plan where I can find some median equations and find out where they intersect. So my plan would be to use the midpoint and an opposite vertex to get median equations. And at this point, if you need the practice doing that, you should stop the video and actually take the time and do the practice to get the median equations. To save time at the moment, I'm going to provide two median equations that I worked out. I did the median from vertex A, and from vertex A, there's the median equation. I did it in point slope form. From vertex B, it was very easy because B is a y-intercept to come up with the point slope form. And now I need to solve that system of equations to find where they intersect, and that intersection then will be the centroid. So, starting with the pieces that I have, I'm going to take a look and see that substitution wouldn't be bad, but I'm going to go back to UAS4 and say, if I multiply everything through and clear denominators out, I may feel more comfortable doing the work. So before I do anything with this top equation, I'm going to multiply both sides by 9. 9 is the denominator, and therefore my new equation that still represents that line, 9y minus 9 equals. The 1/9 and the 9 will divide and make a positive 1 multiplier distributor. I'm going to leave it like that for the moment. You know what, now I'm going to move it into standard form. I'm going to bring my 5 over, so I'm going to add 5 on both sides. I'm going to bring my 9y's over, so negative 4 is x minus 9y. Okay, so that's my new first equation, a little bit easier to work with. My second equation then, I'm going to multiply everything through by 6 so that I have a new equation without denominators. So I'll have 6y is equal to the 6 times the negative 13, 6 will just be negative 13x. The 6 times the 5 is 30. Again, I'm going to choose to move this one around into the same form as the equation above it. So the negative 30 would come to this side. The 6y would come to the other side. They're all negative, they could just as easily be all positive if I multiplied everything through by negative 1. Now these are the two equations whose system whom I'm going to solve as a system. So coming over, I'm going to move these down where I've got a little more room. I'm going to choose to do elimination. I'm going to keep that bottom equation with negative 30. Different plan. I'm going to aim to get rid of my x's or my y's. Let's go for x's. I'm going to multiply everything through in that equation then by 13. So in that equation with x minus 9y, I'm going to try to get a 13 x's in there so that I can do this. So I'll have negative 52 is 13x minus 13 times 9 is 117, I believe, but I'm double checking. Yep, 117y. A little bit obnoxious of numbers, but you can handle it. Moving over my other equation then, the green one that I don't need to move around, negative 30 equals negative 13x minus 6y. Alright, getting rid of my x terms, I have negative 82 equals negative 123y. Okay, and dividing both sides then by negative 123, I get my y value being 2/3. Okay, it is wise to leave this as a fraction, not using a repeating decimal. You might lose accuracy and have a very goofy result. So far I've got 2/3. Now I need to go back to any of my equations that have both x and y. I can choose the ones I've been working with. I can go back to the original, choose any version of the ones that I have. Just for the sake of argument, I'm going to grab this one. So negative 4 is equal to x minus 9 times 2/3. Negative 4 then is x minus 6. The x value comes out 2. So the centroid for this one, meaning the intersection of its medians, is going to be when x is positive 2 and y It's 2/3. As you work through the homework, much of this is steps from the past with centroids, circumcenters, and things like that. You may need to go back to your UAS3 and your UAS5 and take a look at how you found some of those equations, then patiently work through the algebra. Cutting steps and skipping steps usually goes pretty badly. So tonight, work on your UAS6, use the online key for help, and show your algebra.